Welcome everybody, thank you for joining today's webinar. I'm here to talk about lead screws and the use in 3D printers and CNC applications. My name is Nick Isabella and I am the Dryspin SD Product Specialist for lead screws here at igus. For those of you who are not too familiar with igus, we were founded in 1964 in Cologne, Germany. We have since expanded to over 35 countries across the globe, several thousand employees worldwide. Here at our location in East Providence, Rhode Island is where we are headquartered for all of North America. So this is our distribution center for the US, Canada, and Mexico. This facility is constantly growing. Every year we seem to be making new plans to continue and expand our facility here. Some of the new and exciting things that we're looking to do in the next few years, our 5-year plan, we've actually already started to expand at an old facility down the road from igus, where we are starting to produce and do injection molding here in the United States rather than solely relying on our headquarters in Cologne, Germany. Currently, I believe we have about 40 injection molding machines, and we have quite a few goals to add more as well. We also have a number of sales reps from across the country. All of these sales reps are able to do in-person visits with all of you to discuss your applications and find out if igus can help provide a solution for your application. igus has a number of different product lines here. We're split up into a couple different divisions. So we have our cable carriers as well as the cables that go inside of them. A number of these are used in the packaging industry, 3D printing industry, and are found quite commonly. We have a number of different components that we provide to our customers here at igus. However, at our core, we are an injection molded polymers company. So we specialize in creating compounds that are filled with all different types of fibers and filaments and solid lubricants. igus's goal is for you to get products from us that are maintenance free, where you do not need to use an additional lubricant with our materials. Our headquarters in Cologne, Germany has an extremely large test facility. This test facility is used to rigorously work through all of the different materials that we're working on, all of our different products. Everything is revolved around life cycle testing. So we're making sure all of our parts are going to last long for applications. And then all of that information is continuously fed into our online tools that we'll talk a little bit more about today. Now, specifically with our dryspin product line, we have a number of different components that we can provide to our customers, so that way they can get everything they need from igus as a sole supplier if they so choose. We have all different types of lead screw thread profiles. We provide what we call our dryspin lead screws. We have standard trapezoidal and Acme lead screws as well. We have over 9 different standard lead screw nut materials that are specialized for all different types of applications, whether you need temperature resistance, FDA compliance, you name it, we have a material for it. We have a number of different components that we've engineered to help reduce clearance in applications where customers are looking for accuracy and precision. We have metal housings for lead screw nuts, end block supports, specialized lead screw nuts for misalignment, as well as spindle motors and controllers for those applications as well. We also have a handful of different lead screw materials as standard catalog parts, but we also provide customers with custom materials if they need them for their applications. Now, when it comes to 3D printing applications and CNC applications in particular, there's a lot of different scenarios that can play out that determine whether or not you decide to use a screw-driven axis or a belt-driven axis. I typically find that customers are looking to achieve several different things. They're looking to expand their print bed or their workspace for their CNC. They're looking to achieve higher speeds to maybe increase their opportunity to print more parts per hour. Maybe they're looking to provide the most accurate print as possible. Maybe customers are sensitive to cost. These are all different factors to weigh when you're trying to pick what you use for your application. Now, in regard to belt-driven products for CNCs and 3D printing applications, there are a number of different pros and cons, as well as lead screws. What I find, customers typically gravitate towards belt drives for long stroke capability, high linear speeds, high efficiency output, and they're looking for a product that has a very high uptime. Now, the cons to belt drives in particular are very high costs compared to that of a lead screw application. They have lower accuracy, they need to be maintained, and they struggle with shorter stroke applications. Now, a lot of the maintenance comes down to the fact that you need to continuously maintain the belt tensioning in an application. And then with short stroke applications, what we find is that when the belt is constantly going over the same portion, it's wearing more in that one area than, equal wear throughout the belt. So that actually will then increase more clearance into the system. That'll cause problems for accuracy, and that'll need more maintenance to basically take that clearance out. On the other hand, with lead screw driven applications, we tend to find that these systems provide a lower cost to our customers. They provide a higher accuracy, and there's a significantly larger number of different products to choose from. There's all different size diameters and leads, or pitch, if you prefer, to choose from. Now, lead screws do have limitations. Screws aren't going to work for every single application out there. They sometimes struggle with high load, high speed applications. Specifically with polymer lead screw nuts, you need to be sensitive of what we call PV values. So that's the combination of load and speed in an application. That it has to do with heat generation and how our polymers wear, whether it's an igus polymer or a competitor's polymer, whether that's PEEK or just a simple acetyl nut that's Delrin, POM. All of those things need to be considered when you're looking at an application. Now, where lead screws also tend to differ from belt drive applications are the speed limitations. When customers think about, oh, I want my application to be as fast as humanly possible, they're looking to spec in a belt drive. What I'm here to talk about today is mainly where maybe we can make some optimizations. You can continue to use lead screws to widen that range of application use for the customer and use a lower cost option as a solution. Some of the common problems and solutions that we find with lead screws in particular for these applications, like we were just talking about, is the stroke length. Typically when you think about a lead screw for an access, you're basically looking at a smaller product that's going to cover a smaller footprint. Whereas belt drives can scale up. As long as you can make a belt, you can make a longer axis. Now, one of the things that you can do to continue using a lead screw for this application rather than moving over to a belt drive, you can move up in the diameter of the lead screw. So rather than using a smaller diameter, you can bump up the diameter to achieve higher feed rates, linear feed rates per minute for your application. You can increase the lead of the screw. Number of the last few years, we've expanded our high helix product line and our dry spin lead screws significantly, and we're constantly adding new products to that portion of our product line. By increasing the lead, we're decreasing the RPM. So basically, you're achieving the same linear feed rate, if that's your goal, is to have a higher feed rate, but the actual rotation speed of the screw per minute is going to be lower. So that bodes very well for using a lead screw. Now, a number of different things come into play with lead screws and lead screw nuts. Axial play, you want to increase the accuracy in the application, the accuracy of the print, the tolerances of the final part. Some standard lead screw nuts might work for some applications. However, igus does have a number of different clearance reducing options where we're removing backlash in the system and you can achieve a more precise print. Now, one of the other limitations of a lead screw is the noise. One of the things that you can do to alleviate that is to utilize a screw with a longer lead. You're reducing the RPM, you're reducing the chance to get that whipping noise that's causing binding in the screw. That binding typically is presented in a grinding sound. It can be presented in a squealing sound in the application, depending on the part, whether that's a polymer lead screw nut or a metal nut. Especially with metal parts, as they're not maintained and continuously lubricated, that's the type of noise that you would end up hearing in an application. One of the other things that you can do to help combat noise using longer lead screws for larger axes and print beds is actually increasing the straightness tolerance of the screw. So a standard lead screw that igus rolls will come off at 0.3 millimeters of straightness per 300 millimeters of lead screw. So the longer your access and the stroke length of the application, that tolerance continues to stack up. One of the things that we do offer as an added service, and that can help with these problems, is to actually straighten the screw further to a 0.1 millimeters per 300 millimeters of lead screw, and that makes a significant difference with the application. Now, some more considerations for using lead screws in 3D printing and CNC applications, especially for extremely long strokes. A lot of CNC applications tend to have workspace areas that exceed maybe a meter for the X or the Y axis. One of the things that you can do to help avoid sag and whip, that natural bow that can cause binding in the application and noise, is to actually hold the lead screw and the end supports in tension. That tension basically helps keep the lead screw straight in use and helps reduce that whipping motion that you would find. Also, how you're supporting your lead screw in your application. There's a number of different ways to support a lead screw. You can do it in a fixed manner, or on this screen, as you can see, in a tight manner. We have what we call fixed simple or tight loose. You have loose. And then by far, what I find to be the worst scenario to support a lead screw would be a fixed free. Typically what I see, especially with Z-axes, vertical axes, customers will sometimes use a fixed free method for their Z-axis. This becomes a problem because as the lead screw nut gets closer to the actual support of the screw, the end that is supported, the other end tends to actually move off axis. That can cause binding, that can cause excess wear in the lead screw nut, and that will end up causing other issues with the print in general. And the last thing that I would want to note is making sure that you're properly reviewing the linear guides that you are using in the application. igus has a number of different types of linear guide profiles, from our Dryland W that I find to be extremely popular. There's our round shafting. We have Dryland T, just a standard T-rail, and then we have also some very low profile guides as well. Now, on top of that, especially for higher speed applications, maybe higher load applications where we need to reduce the friction as much as possible, customers can utilize a linear ball bearing for their guide and still utilize a lead screw as a sliding mechanism to actuate the application. This does benefit the lead screw. The coefficient of friction in the application is greatly reduced, so that drives the torque required to move the load way down. And it also provides quite a bit of precision in the application. There are limitations to sliding components. Now, igus has a number of different clearance reducing options. We have anti-backlash nuts, we have what we call a zero backlash nut, a preload nut, and also a low clearance nut. All of these parts function slightly differently, and some of them do different things. Our zero backlash lead screw nuts provide the best axial clearance reduction, so cutting down on the amount of backlash in the system. Typically what we find you can achieve anywhere from 0.03 to 0.05 millimeters of backlash in the thread. So this will help provide a much more accurate print. Couple that with the lead accuracy of the screw itself. Now we have what we call a preload nut. This is a relatively new product that we released just this year actually. And we've actually continued to extend that product line as of late. But basically this product, rather than using a torsion spring like the zero backlash nut does to separate the two components of the nut, it uses a tension spring. That tension spring does increase the drive force required for the nut just because of the increased friction from the tension spring. So you might want to take that into consideration for a solution for your application if the motor size is quite small. That is a lower cost option, however. Our zero backlash nut has a number of different components that make up the product, whereas the preload nut is just 3 simple components. So that does help provide a little bit of a cost reduction, especially for higher volume applications. And lastly, we have what we call a low clearance nut. So this functions a little bit differently than the other clearance reducing options. This is more concerned with the radial play in the thread. Now, radial play can actually lead to noise, especially in higher applications. You end up seeing the nut bobbing up and down, and that can lead to what is called chatter. The low clearance lead screw nut, it's an injection molded lead screw nut that we do some post machining to add radial grooves, and then we fashion that with radial bands. Those radial bands clamp the sidewalls of the lead screw nut onto the major diameter of the thread for the lead screw. So that reduces all of that radial clearance out of the thread, and it provides a very smooth running part with reduced noise. Now, if our standard products don't work for your application, whether it be the mounting fixture to it or the size of the part, igus has a number of different semi-finished products that we can use to machine you a custom part, whether that's our extruded bar stock, maybe it's our plate stock material, or even an injection molded custom part. Now, for this particular application, for Stepcraft, they make CNCs. They're actually pretty local to us here in East Providence, Rhode Island, not too far away in Torrington, Connecticut. For their M1000 CNC, they utilized a custom machined lead screw nut from igus. And basically in the fixture, they have two custom nuts opposing each other with a tension spring in it to help reduce axial clearance in their application. And that was for their Z-axis. Earlier in the presentation, I discussed igus's vast test lab facility. All of those tests that we have ongoing, usually 24/7, feed into our online lifecycle calculators. Now we have different calculators for all of our different product lines, so it's not just for lead screws. All of our parts are meant to be calculatable and configurable, so you can make customized products on our website, but you can also get all the lifetime information for our products. Now the lead screw configurator, I find it to be probably one of the most easiest to use tools that we provide to our customers. You only need 4 data points to make it work: the load, the speed, the duty cycle, and the stroke of the application. That's about it. From there, your application can get a little more specialized. We provide the ability for customers to include any chemicals that might be encountered in the application, any temperature ranges that we might see in the application. Because igus has different specialized materials, those factors would change what we would recommend for an application. Other than our standard tests that we do that feed into our calculators, we also provide the ability to do custom lab reports for our customers. So if you're using, maybe it's just not a standard part from igus, and we're making you a custom component and you want to have that tested out and don't have the ability to do it on your own, you can provide to us all the information that you would need for a test, whether that's accelerated testing or just standard use case. And we will basically make up a rig to do the testing for you at our facility. One of the lead screw nut materials that went on to become a standard catalog material was actually originally tested for an industrial 3D printing company, and it proved out so well that we added it to our catalog. And it all came from doing internal testing for the customer. You can see here we have a couple different wear charts. So most importantly, you can see the difference between our igus polymer and just a simple Delrin lead screw nut. The wear rating is vastly different. And then between our own materials, so we have our standard iGlide J lead screw nut material. It works for about 80% of applications. Then we have our more specialized materials. igus made a iGlide E7 lead screw nut material. This material excels especially for CNC and 3D printing applications that you're looking at high speeds and low loads. Comparatively, E7 and iGlide J are significantly different when it comes to wear ratings. And E7 provides sometimes, in some cases, millions of cycles for customers. So one of the things that I've been mentioning all throughout the conversation here is the word dryspin. Dryspin means a number of different things at igus. It refers more broadly to the entire product line that encompasses Acme trapezoidal lead screws, but more specifically our dryspin lead screws. Dryspin is very special. It is a patented thread geometry that igus created, and it differs quite a bit from standard Trap and Acme thread profiles. Trap and Acme are considered symmetric thread profiles, where the ratio of material from the lead screw thread and flank to the nut material is a 1-to-1 ratio. Whereas with our thread geometry, we call this an asymmetric thread profile. So we allow for about 30% more nut material to be used in our applications. And this provides more material to wear over time, so it's naturally a longer lifetime for the part, being the lead screw nut is the wear item. Now, it doesn't end there. The thread geometry itself has a curvature and rounding of the tooth, and this helps reduce noise, especially in higher speed applications. Now, probably one of the biggest differences between dry spin and standard Trap and Acme lead screws is what is called thread class. Trap and Acme adhere to ISO thread classes, to ASME thread classes. All of these are dictated by min-max dimensions for the major diameter of the thread, whether that's the lead screw as an external thread or the internal diameter of the lead screw nut. Those min-max dimensions cause a problem in applications, especially when we're looking for a high amount of accuracy and precision. Dry spin is more of a precision product. We control the dimensions of the thread and we provide a more precise product. So the major diameter for the majority of the products is a +0, -0.1, and the same type of dimension for the minor diameter as well. Now, when it comes to all the different specialized materials that igus has to provide, we have over 50 different 50 different materials at igus. We have over 9 different materials specifically for lead screw nuts. Some of the standard materials that I recommend specifically for 3D printing and CNC applications, because they're typically higher duty cycle, higher speed applications, we're looking for materials that have very good wear resistance. So as noted before, our iGlide E7 nut material is probably one of the best for these types of applications. However, it is ideal for low load use. So maybe some smaller 3D printer applications where the loads are manageable. Now, as we're increasing the load, we do have some other materials that are going to work a little bit better. So our J200 lead screw nut material is best when it's paired with an aluminum lead screw. And this actually has some of the best wear rating and wear resistance across all of our lead screw and nut material combinations. The only caveat to this is the fact that aluminum lead screws typically are rolled here at igus at 16 millimeters in diameter and up. Then we have our most commonly used material, iGlide J. And for more specialized applications, for example, a 3D print bed where the lead screw and the nut are enclosed in the bed itself where they might be subjected to higher temperatures, we have what we call iGlide J350. Now, as we mentioned before, we have a couple different lead screw materials here at igus. All of our dry spin lead screws come standard as 304 stainless steel. Our Acme and trapezoidal product lines have a number of different standard 300 series stainless, but we wanted to make it universal specifically for our dry spin products. And then we also have the ability to provide aluminum lead screws, especially for applications where customers are looking for a lightweight product for their application. Now, if our standard lead screw nuts are not going to work for your application, whether it be the mounting structure, the overall size of the part, maybe we need a longer thread length, we have the ability to make custom parts here at igus pretty easily. Our rapid prototyping custom parts are 3D printed in-house. We have laser sintering capability here in the US. The online tool allows you to drag and drop your step file into the tool, and that pricing tool will actually spit out a price to you that will keep lowering based on the amount of available room in the print bed. One of the other ways that we can provide a custom part to our customers without investing in a production tool is what we call print to mold. So our print to mold process, we have a number of different materials that we can work with for this, but more specifically with the tool itself, this is a laser sintered steel tool, and the lead time is typically about 2 to 3 weeks to get an injection molded part that is custom. The cost is very easily and manageable. to get started with a print to mold part. And these are very ideal for customers that are moving forward with their design, they're hashing things out, and they want to see how that part is actually going to function without investing in a production tool. Our SLS laser sintered parts, however, they have different wear properties, the materials function differently. I find that the laser sintered parts are very ideal for customers that are getting off the ground. They want to get a part that is going to fit into their application just for form purposes, not necessarily doing high duty cycle testing or even accelerated testing with those parts. The materials do wear quite well, it's just not up to snuff compared to our normal catalog materials. So that's when we would recommend that customers segue and move to the print to mold features that we can provide to our customers. Now, just talking a little bit more about some of our 3D printing materials, we do have the ability to provide customers with FDM filaments, and we also have resin that we have made as well. And we do sell our SLS powders. Like I was mentioning, the wear resistance of these materials is quite good. It's just not as good as our standard extruded bar stock materials or our molded materials. They just function differently based on the production method. Moving away from custom lead screw nuts and our standard products for lead screw nuts, it's more or less talking about the custom screw itself. So directly through igus's website, we have a number of different custom part configurators. So our online tools are very interactive. You have the ability to make a fully customized lead screw, and it should be delivered in anywhere from 3 to 5 weeks is the standard lead time. The online tool scales up in pricing up to 49 pieces, so if you're just doing prototype parts, this is the perfect tool to use and get started for your application. So whether you're adding just simple journaled ends, maybe you're adding a keyway, feather key grooves, maybe you need to utilize the lead screw with a stepper motor and just directly couple the screw to the motor. So you can add secondary thread profiles to the journals that you have machined onto your screw. Now, the tool doesn't just provide a price, it also will give you a 2D print that you can download as well as a step file. So this tool can help take care of everything that you need all in one spot, and you can do it completely on your own from your office. igus has a number of different additional resources that we can provide to our customers. We have what we call the igus toolbox. So this is a compendium of all different types of materials, from our white papers that go into in-depth tech talks. We have blog posts on here. So there's a lot of really good touch points that customers can take a look at to get ideas for their applications and see if products are going to work for them. Some of these blog posts tend to be industry focused. Maybe it's in very specific application. For example, customers looking for clean room parts. And then we also have a lot of our different online materials, and we're constantly filming videos for customers via our YouTube page. And I highly recommend that all of you check out those product videos. I thank you all for joining today. We'll move on to the questions portion of the webinar. You can see here we have a QR code on the screen if you would like to get a sample from igus. This is specifically our dryspin sample card, so this talks about the different products that we were featuring here today and the different lead screw nut materials that are good specifically for 3D printing applications.